right, I'm Luther Kruger with the Big Blue Sun Museum, based in Minneapolis, Solar Cooking Museum. And I'm here in Patrick Sherwin's beautiful home in Cincinnati. Thanks so much for having me. This is number 4 on the trip. This is a great opportunity to talk about the trend. I think in the last 4 or 5 years has been people really looking seriously at vacuum tube cookers. But before getting into the GoSun, the one question I always ask is, how did it start? When was the first time that the sun dawned on your imagination for use for solar cooking, for solar energy, for what have you?
Boy, wow. Well, thanks, Luther. This is a treat to have you here. I love what you're doing, running around the country capturing these stories. Boy, that's a tough one. I don't know if I remember when I first experienced solar cooking. I can tell you that what was the Good Earth catalog?
Sure. Whole Earth?
Whole Earth, thank you.
Yeah.
The Whole Earth catalog. I think I read that cover to cover as maybe
Sure.
a teen, maybe 15 years old.
Yeah.
And then, of course, John Schaefer and Real Goods catalog was another big one. I started having those sent to the home when I was about the same age, and would drool through. I'm definitely a product-centric type of mind, so I'm always looking at gadgets and the fact that you could cook a meal with the sun. I think probably the first experience was in a catalog, just looking at it there.
Sure.
And then I believe my first experience actually cooking was not until I was probably about 19 years old. I got a job working for a solar installer.
Oh, sure.
In the small town that I went to college in, Athens, Ohio. And Matt Bennett, wonderful leader of this company, who was very committed to living the good green life and was living off grid, and he brought a sun oven to work one day, and we cooked up some kind of a casserole or something, and I was just thinking,
sure,
amazing. So it's love at first sight when that happens. Any excuse for me to use the sun,
yes,
I'm in.
Yeah,
it just makes so much sense.
Great. Well, and then segueing, you're an entrepreneur. You've set up this company with a very distinct product, and some people think of it as a niche community, but we all hope to make it a standard operating procedure for folks around the country. So how did that happen? When did you first discover the vacuum tube, or decide to think into going into making solar cookers?
Yeah, I was on a decommissioning project where we were taking a solar hot water system off of a rooftop. Wow. It was actually here in Cincinnati in like 2002. We were the lucky company that got the phone call, a guy that had this installed back in the 80s. Hey, I want this thing off my roof. It's starting to leak. It hasn't worked in a decade. All right, we'll be right out, And instead, we moved it off the roof, and, it still worked. It hadn't worked in a bunch of time, but, I just had to replace some sensors and pumps. And I was tinkering with I had about 4 8x10 vacuum tube arrays that were made in Toledo, Ohio, back in the early 80s. And rather than throw them away, I thought I'd bring them home and play. I still have some of them. And I couldn't figure out exactly how to get everything working just right for domestic hot water. But I did know that this thing was 500 degrees hot and 1 inch in diameter by about 6 feet long. So I thought, what else could I do with this? And the hot dog.
Yes.
The hot dog dawned on me. And being here in Cincinnati, this is Porkopolis. We of course had a hot dog in the fridge. Grabbed that, I tossed it in. The tubes were racked vertically, and it sizzled on the way down. I thought, whoa, this is cool. And I used a bunch of solar ovens at that point in time, including a trip that took me to Haiti, where I got to see firsthand the need for these technologies, and had played a ton with panel cookers and box cookers, and so I knew that the evacuated tube was going to be really an interesting contribution, but that was so early on. I didn't know it was only hot dogs. It was 6 feet long and 1 inch in diameter. It's like the contribution.
There's a volume concern there.
Exactly. And so that took maybe 5 years as a muse to figure out how to iterate on that to build like a consumer level product. In fact, just going from every evacuated tube array that you've ever seen was this way. So just putting it horizontal took, it's just such a simple innovation, but it took Lego kits and constructs and models before I started to figure out the simplicity of racking it here, putting a stainless steel canoe tray to bring food in and out, to develop the reflector arrangements where you could catch the sun the right ways.
Sure.
And the rest is history. It took about 50 prototypes and a decade before the first version was ready on Kickstarter. We launched the business in 2013. It's going to be about 8 years from now.
Okay.
And we launched it on Kickstarter.
Wow, that long.
Yeah.
I vaguely recall getting the mini. I think it was just the mini.
Yeah.
With a little, almost like a balsa frame.
Yep.
Yeah.
Yep.
Yeah.
We hand built those right here.
Yeah. There we go. Yeah.
Yeah.
Yeah. Wow.
So were you involved in backing that campaign 8 years ago?
I think I got that. I know I got the Fusion through Kickstarter. I don't remember if I got the Mini or not. If that was part of it.
Because that was
I think I got it, and the next step up.
Yeah.
Probably in the same. I don't know if they were in the same package.
Yeah.
Yeah.
That was 8 years ago.
Yeah. Yeah.
When the campaign launched,
Sure.
and then you received it about 7 years ago.
Sure. Well, and I have to comment on the angle of the tube. The first vacuum tube cooker I got that looked like it really was going to have a substantial amount of volume. The HIMIN, I don't know how it's pronounced, but from China, and it's on a thing where it has to tilt forward, and it's almost like you can only boil water for tea because it's just that extreme angle.
Right.
They've got tubes that you can put food in, but then what if let it in that a little too long, and all of a sudden that just congeals to the tube? So doing it horizontally is just, for me, it's the only way to go. I mean, and being able to. I mean, you have to adjust that one anyway, and you got to adjust it in 2 or 3 different directions, whereas you just slide this one around, right? I mean, so just good move is what I'm saying.
Yeah, it's such a simple, intuitive deal, but it took a lot of tinkering, a lot of prototypes, a lot of broken glass. I kept finding the vertical would create funny temperature stratification, and then a lot of stress on the neck where you would have air temperature and then water. If the water was 100 degrees F and the air is 600 degrees, that's hard on that glass.
Oh yeah.
So
I actually one of my episodes with Craig Bergland in Reno, Nevada. He does everything with solar. I mean, everything. Roasting beans, making hydrosols, distilling absinthe. I mean, we're talking everything. And so I get back, and he's got a rack with like 6 or 8 of the vacuum tubes, about maybe an inch or two wider than that one, not the Fusion size, but he roasts beans in that too. True confessions time. First time I saw vacuum tube cookers, my first thought was, that's cheating. That's cheating. That's because of high heat and all that. But people obviously have been won over by it. It works. And you've been through the trial and error, and the errors are going away, and but you keep doing the trials. You've got a new model that's come out, I see.
I think we have 5 stoves now.
Okay.
And the Fusion, I think you mentioned, you've played with that, is was the last oven that we launched, and that's been about 3 years.
Sure.
So we kind of moved into other things as a business. We did solar cooling, like these portable fridges, charging and lighting. We launched a coffee brewing system recently because trying to fight fires, like when you go to a campsite, you have to have propane. Sometimes that's being banned now. But you need your coffee in the morning.
Yes.
And solar's not perfect for that because morning light isn't going to be perfect. So we came up with a little 12-volt French press travel mug coffee heater thing.
Sure.
We did a water purification and sanitation device, but anyway, this is more about the cooker side. Yeah, we're about to launch a cooker that's super inexpensive. It's designed to be like a kit, so you assemble it at home, made of just really simple materials. The reflectors, as you probably know, throughout the industry are notoriously the big cost when you get into anodized aluminum. So we found a material that does the job out of the lighting industry. Altogether, it should be around $40, and that'll be a third of the price of our current ovens.
Okay.
So we're pumped about that. Trying to mainstream, trying to promote this as far as to as many families as possible.
Mm-hmm.
We don't, and we want to try to see if we can get it into stores, onto the shelves.
Sure.
I mean, why not?
Yeah.
And we're taking the hit on margin. These things aren't cheap, the tubes and the arrangements, but to try to get the message, the power of the sun in more people's hands.
Sure.
Because once you're convinced that the sun has the ability to work for you, then you'll probably try to build it into your life to, eventually fuel your entire car, your home.
Sure.
The people that you're talking about who live off grid. I mean, should we all be so lucky someday?
Yes.
But there's really, the sky's not the limit on solar. You can cool with the sun. Food can be processed with the sun.
Sure.
And we've all seen that. I'm sure you helped to reveal that a lot through your channel.
Well, and if you follow the UK solar cookers group on Facebook, this is one thing they really focus on, because if we're in the variety weather belt, they're in the mostly fog times and
this kind of weather.
Yeah, they just feel like they have too narrow opportunities for like a parabolic even.
Yeah.
But like a rack like what you have outside, which I'll have to get a shot of on the way out. They came up with what they called the McTilty, which is 2 or 3 of them, kind of like that, and it's just mounted flat on a wall.
Yeah.
But with the reflector curving in and then flat and then curving back out under with the 3 of them, and that they feel like that. Okay, even if you have that narrow window, it'll cook faster. But say slightly overcast, where you can kind of make out the sun behind the clouds, they'll still get some slow cooking power out of it. So
that's a powerful part of the vac tubes is that they absorb a wide spectrum of light and just let that heat accumulate. And we've used them in blistering cold, and I can't believe, like, I did this thing a couple of years ago. I took a challenge when I turned 40 to cook exclusively on our products for 40 days and nothing else. And it was in February and March, and this isn't the sunny place in June, as you can see, but February and March are pretty gray, just like Minnesota, I'm sure. Probably even worse because we're in the Ohio Valley. And there was days like I didn't see the sun for 28 hours, and I was getting really hungry. I had 7 eggs in there, kind of hard boiling, and put them on the table and they spun. They were still a little runny, but I hammered them down like Rocky Balboa. And, just shocked at how much energy these things can absorb in even some of the worst light conditions.
Sure. Well, and one question I've always had, now that my collection has grown so far, and I've seen just about every configuration: box cooker, parabolics, the tubes. I actually had one that, because of my little alert on eBay, it says solar oven, and it's got a Fresnel lens, but the Fresnel lens is only like 6 inches, 8 inches. And I'm thinking, well, how can that be that'll do something. You can fry ants, they did as kids with magnifying glasses. But I get it, and it says, okay, it's a kit, and you have to make the base, and it's from the 50s.
Wow.
Now, and the instructions are, go to your hardware store and get what they call asbestos clay. I'm thinking, oh, well, thanks, but no thanks. But is there an option besides that? Well, and I remember NASA came up with a really high-tech ceramic that literally, you take it out of the forge, it's red hot, and you can hand it to someone and they can grab it because it dissipates the heat that quickly. So I asked around, and people said, yeah, there's all sorts of stuff like that. There's no asbestos, it's really earthenware kind of stuff. But that's why they fire, the kilns and all that. But the question is always, as you say with reflectors, getting the materials. And lately, people I know that are replacing tubes or upgrading, they're saying they can't get like the RAN tube or the wider tubes for love nor money. Is that a challenge? Is that are they made here? Are they made overseas? How do you keep on top of that kind of thing?
It's a pain. Yeah, I mean, to my knowledge, the evacuated tube was developed and engineered primarily in the United States in the late 70s, early 80s, probably largely triggered by the Carter era administration's solar tax credits, which were unreal.
Sure.
I mean, like, I think there was like upwards of 90% tax credit
Oh my goodness.
at one point.
We got 30% for our solar panels,
Right.
and that was like ka-ching.
Yeah.
Right?
Yeah. So, you know, there was all this innovation that just jumped, you know, and Carter's thought of as the godfather of the modern solar energy era
Sure.
that we're in now. And so a lot of the stuff was made here and engineered here, you know, came out of the radio industry, evacuated tubes. And then it migrated, Germany, Australia, a lot of innovations were made, and eventually to China. And now my understanding is that 95% of all evacuated tubes for the purposes of solar thermal are made in China.
Wow.
And even that industry now is starting to tank,
Really?
largely because, you know, solar PV has become so much more ubiquitous. It's so much easier to work with electricity than it is thermal
Sure.
energy, especially with water involved. And so what was a big boom in the sort of 90s and 2000s, and a lot of that actually came from, I don't know if you knew, Hua Ming is the founder of Hemin, the company you're speaking
Okay.
of.
Sure.
He really helped to champion evacuated tubes in China, and domestic hot water. You know, the industry in China in the 90s is bigger and more prolific than any solar thermal industry ever seen, and that carried well into the 2000s. But, you know, again, around 2010, when solar PV became much more competitive and ubiquitously available, primarily in China again, also being manufactured in China, solar thermal started to spiral down. We were lucky enough to build relationships right around that same time over in China with vacuum tube manufacturers and still get them and have them make off-sized units. So, you know, generally the tubes were about this diameter,
Sure.
and they'd be, you know, like I said, around 6 feet long, and they'd be in an array of 20 or something for the hot water. And we're building tubes that are their advantage is they want to be narrow and long.
Right.
We want ovens want to be short and squat.
We want to fit a turkey in them, but they will have to be diced up somewhat. But yeah.
That's right. My thing is, look, you're always going to dice up by the time it goes in your mouth, so you might as well.
Yeah.
But we still have a steady supply. You know, we worked hard to get that position, and spent a lot of time over in the Orient trying to figure out more of the supply chain. Is that supply chain ever available in the United States? It's debatable. If I raise $10 million, maybe, you know, I'd like to bring it over here. I really would.
Sure.
But
Wow.
it's hard to compete.
Yeah. Well, that's good to know, because I mean, to a degree, I think people have been aware of it in the last 2 years, 3 years with the economic changes and so forth. But when they're starting to rely on, like in the UK, they're going, oh, I want to get a RAN tube, I want to get whatever, you know, and everyone's telling me we're not getting them. You know?
Yeah.
So it's discouraging, but you know, it can be cyclical too. So maybe it'll come back.
Yeah, I mean, we're gonna stick around.
Yeah.
You know,
Yeah.
we had a product that we called the DIY kit that we launched maybe 2 years ago, and it was just a tube and like a roll of reflector material and a few other things that, you know,
Sure.
you put it together type. And those sold fairly well. They sold out, and that particular tube we couldn't get our hands on anymore. Same thing, very similar thing happened to our product called the GoSun grill.
Right.
That had a really big tube. It was a 5-inch inside diameter. Boy, I can't remember exact dims on it, but basically we pushed everything for that product, and we did it at an early stage, which was a big mistake for the business. It was like launching Tesla Model S, but not having a team of rocket scientists and car engineers, you know, from Toyota to deliver. So we figured it out, we delivered, but it was like way more expensive and difficult to build than we had anticipated. So we kept it alive as much as we could, tried to innovate on it, but it was just killing us from a cost perspective. That's pretty much why the product is no longer being manufactured. It was a cool product, a lot of people liked it, a little slow for my taste. It's slower than the Fusion. Speed's important when it comes to cooking. Obviously, people who cook in solar ovens are going to have different demands, and speed may not be the top.
In fact, one question I've always had is maybe speed can be a bad thing if it's too fast and you get the thermal differences.
Yeah.
I mean, if you heat up one part of the tube too quick,
Right.
It doesn't take much to shatter.
Like a little bit of water can break it. Yeah.
So and that was one question I had, was maybe that was a purpose, because people have said that, well, it's slower than the Fusion, because people had both. And I was wondering if it was a conscious choice, or it was like, well, we put it out, and then that's what you got.
Yeah, I'm not going to say everything we do is a conscious choice.
We thought,
but it was on the grill. Part of everything has been thought of. We're on a 20-year plan.
10 experts.
We got AI and data coming in. But basically, we knew that the grill was the kind of product we wanted the customer to be able to sit on the back porch and leave open all day. Come home from work, it's preheated. Yep. It's 400, 500 degrees, toss dinner in there and go. Yep. So we also made it to where you could preheat it and it wouldn't develop that thermal shock potential. Mm-hmm. Thermal shock was something I was more worried about than I am now.
Sure.
And what does I mean by that? Well, when I first launched GoSun and shipped 1,000 units to the general public, I thought, oh boy, here we go. This will make or break this business. I took a lot of precaution. I broke every tube I could find. Tested the heck out of this. But when it's in the hands of the consumer, who's not going to read the user manual, is going to treat it poorly, and the kid's going to run away with it. But turns out our customers were fantastic, and the whole solar cooking community is aware and wants to do something new and different and innovative, and is willing to learn.
Sure.
And we had almost no thermal shock issues, even for people that let it preheat. I mean, there was that episode on Top Chef where someone actually broke it.
The three different chefs, and the one of them put soup
out
in there,
Palm Springs, and so it can happen. But it's basically thermal shock is kind of the best way I've had it described is the bond of glass is being held through a lot of kind of flexible in and outs, and eventually, if you just stress it enough over time, and that's a poor way to say, but it really depends on the amount of temperature difference. So if it's like 500 degrees, where you have the oven empty and preheated in the sun for an hour, and you pour a bunch of 50-degree water in there, that's the worst you can do. Is it going to break immediately? Not always. Mm-hmm. There's so much. Glass is funny. It's it's definitely nuanced compared to metal. It's much, or even plastic. All of them have kind of their characteristic crystalline structure. Mm-hmm. And there's an engineer can talk to you for days about.
Well, I remember someone who knew what they were talking about. I didn't, that's for sure. Saying, actually, glass is a liquid or fluid or whatever they call it, where it's like that window is eventually going to be a little thicker at the bottom in 100, 500 years or whatever. Yeah. So it's a material we don't understand 100%. We've gotten to where we're able to use it as safely as possible. Back to photovoltaic and the Fusion. That's the first thing that appealed to me, was being able to have that tray that heats up on its own. And I was skeptical about how long it could be held, but the battery pack, how many hours will you get that heat? Because you're familiar with the hybrid cookers, say like the Sun BD Corporation, David Chalker with his Ugli, and the Tulsi hybrid, where they're the box cooker with the reflectors, but then they've got a heating element in the bottom. Was that something you were aware of before you came up with that, or is that kind of just...
I was probably aware of them, but I regret that I've never bought one of those to play with. We were going down this path working with evacuated tubes so quickly that, I'm really into physics, and I just knew fundamentally that much less energy consumed by virtue of being inside that vacuum.
Sure.
The challenge for us was 100% in how to electrify that heating system. Originally when we launched the grill, we thought we might have a phase change material.
Okay.
And we did a pilot study, and this was the grant we received from the Clean Cooking Alliance from Washington, D.C. It's a part of the UN. And they sent us to Guatemala for a 6-month pilot study. I'd love to share that with you.
Well, that'd be fantastic.
It was fun.
Yeah, yeah.
It was, like kind of like what you described with your buddies who went to Peru.
Mm-hmm.
We went to town on ideas, and it was at the time where the business was brand new, so we were at the peak of our inflated,
expectations.
Yeah, exactly. And we'll make this thing do everything under the sun. And so we did. We had all kinds of ideas. We worked a lot with local communities. We worked in urban areas and rural areas. And we came up with all kinds of stuff. And one of the big things that came out of that, since most of the time we were there was during the rainy season, every day at about 3 p.m. you'd get a storm. And if you didn't have dinner cooked, you're out of luck. So we need the ability to cook in the evening, at night, after a storm, whatever. So we have to store heat was the answer that we thought, rather than create heat with electricity. And how do you store heat? I mean, can you just use sand, basically sensible loads, just thermal mass? It doesn't really work well enough. Well, let's try this phase change material. Again, I've got a background in chemistry, and so I wanted to, so we played with that, and we got something working. But long story short, this ball of wax wasn't repeatable. It wasn't able to be cycled over and over and over like we had hoped.
It deteriorated?
Yeah.
Okay.
Like it worked for 5 times. So I'm like, all right, we're going to launch this. This is perfect. We figured this out. We went through hell and back. I worked with an MIT prof. Can't remember his name. And this is going back, 6, 7 years. You'd love to meet him. I don't know if he's still around, but and we got this lithium nitrate working, and then we just saw this steady disintegration, and after about 40, 50 cycles, it really wasn't doing its job. Wow. So I was like, we can't sell this. So we had to refund everybody for that thing, and then we pivoted into electricity, which took us another couple of years to develop the fusion. And then how do you get that electricity in there in a way that's durable, easy to use, directly involved with the food? We want to create conduction. It's much better heat transfer than radiation. We don't have the luxury of AC power and 1,500 watts or something. So we came up with this Kapton encapsulated printed circuit board, which is quite beautiful on the back side. In fact, I could grab one.
Sure. Yeah, after we're done talking, we'll do a little...
Go around and we'll show and tell.
Yeah.
And that little puppy only pulls about 140 watts, and it gets the job done. I mean, it's not as hot as the sun. I figure it's hard to talk how really hot is any solar oven. What's the metric or the rating? Sure. I know Alan Bigelow's doing a fantastic job trying to get to that number. I usually use temperature. So the fusion alone is about a 320 degree solar oven for just regular cooking all day, every day in the bright sun. The electric version, if you're not using the sun, is about 240 degrees Fahrenheit. So it's hot, it'll cook a meal, it's going to take quite a bit longer.
Sure.
Ideally, you're using that as a backup when you just need to get the job done. We have a new product called the Sizzle, which also runs on that same fusion tray, and fusion tube. And that product will do 650 degrees Fahrenheit. It's
with the sun?
With the sun.
Okay.
So, and we are working on, in fact, right over here, you can see in my kitchen here, see those 3 tubes?
Oh, sure. That's
an internal electric GoSun that we're using. Quartz heaters each one of those burns about 400 watts.
Okay.
And in fact, my partner just made some bread before you guys came. That's kind of like a long R&D project, but those use about a quarter of the energy of a toaster oven.
Oh, wow, okay.
And
the quartz, they're kind of like those quartz personal heaters you can get for room?
yeah, it's just we just found them in like a rod form.
Okay, sure.
It looks just like a toaster oven. I think the problem is still heat loss.
Yeah.
You know, I mean, induction is a little more efficient than resistant, not much. The problem is that the whole system is in open air, and you're going to lose heat like crazy if you're not heating inside one of those Wonder Bags or a vacuum tube.
Sure.
And that's why I think the vacuum tube is such a powerful innovation, particularly in energy poor areas. Mm-hmm. You know, I want to keep iterating, and I hope people listening do too. Just iterate around innovations with the vacuum tubes.
So when you were talking about phase change and then the kind of what looks like the circuit board under the tray, were there any other options that you looked at, or?
Oh man, we looked at a million,
Yeah.
and I can't even remember. I can show you some of our. In fact, I think recently we archived a lot of that stuff and just got it out of our hair. Resistance was our main heating style, but there's a million different elements within that. You know, one of the problems I still find with the current fusion is, like, if you're cooking something that requires baking, you're generally not going to stir it, and you're going to have all your heat in one spot. So you have to cook. Your recipe has to be something that you can come in and stir every once in a while, in my experience. Like I said, we're working on these here, and we have several different schemes where we have heat above and below, so we get different cook qualities. Sure. We have these aluminum inserts that really help to conduct and move that heat. So that's been a neat innovation. One of my bigger goals, and I'd like to see happen in the next year, is to build kind of a large disaster relief trailer where you could have like 8 fusions or more on wheels with cold storage, prep area, wash stations, sanitization, and then you can cook maybe 60 meals per hour, and day or night, so you really have reliance, because this would be the type of thing after a hurricane or a fire or something, you'd come in and help people out. To have the ability to truly rely on electric if the sun wasn't available, in which case, again, the fusion doesn't do an amazing job 100% as an electric oven. I don't know, does some BD cook on electric alone?
No, and Dave Chalker likes to put it this way: no sun, no fun, no food. And he feels that if there's just, no matter where you are, you're going to have times where you'll want to cook when there isn't any sun, when it's cloudy, when the weather and so forth. And so he just feels like if you're going to develop a new one, think seriously about making it a hybrid. Yeah. And so, so the fusion hits all the spots.
Yeah, I mean, it basically deals with the biggest piece of naysaying. What do you do at night? We've been to 1,000 events, and we've heard everything, and now we have an answer. What do you do when it starts to rain? Oh, let me show you. It's liberating, really. Solar cooking is liberating for all of us. Sure. And cooking is an ancient art, right? I mean, it goes back, forever, and we don't realize it, but we cook recipes that are probably 300 years old, sometimes 3,000 years old, and it's almost, cooking has always been done in a pot on a fire. Nothing's really changed except for the microwave. Yeah. So here we are trying to say, let's do this in the sun. Yeah.
Well, great. Well, we'll close this part, and we'll do a little bit of a tour. Thanks so much.
Yeah, thank you, Luther.
Thanks for this, and especially talking about the history. Going back to the dawn of time. A lot of us, some of us don't remember. I don't really remember, except that I was always, as a kid, I was always into the environment and green stuff, and reading Rachel Carson's Silent Spring and Yule Gibbons, and just being perpetually concerned about the environment, and so
because we're nature lovers at the end of the day. As a kid, you were playing in the woods all the time and in the creeks, and that's kind of where all this comes from.
Okay, this we gotta This we got to talk about.
Yeah, this is the mess right now, but this is the GoSun station. So I really think.
Oh, beautiful. Perfect.
This is Shadow and the GoSun station, and this was built back in 2014. Jose Andres said, "Hey, we want you to come out to this event. We're going to build the world's first solar cafe, and bring something we can commercially cook on." And so we hurried up and slapped together this design. Four barrel, kind of some of the bigger tubes that we could find at the time. A nice compound parabolic reflector. It's on a simple little gimbal joint. Plus you can change the angle. You have about 40 degrees of range.
Sure. And a good rain collector.
Yeah, and a good dust collector. Yeah. It's a mess right now. We still use it. I have to point it to the north because I don't, it'll get 600 degrees or so. And we've cooked about 50 meals at a time. So the trays are quite large, and for example, you can fit maybe 10 full-size potatoes in one tray.
Sure.
Especially if it's cut up in cubes.
Is this the size in the GoSun barbecue or
the grill?
Yeah, the grill.
The grill was a little bigger in diameter. Okay. It was shorter but bigger diameter.
But this is the fusion size?
Roughly.
Okay. Yeah, because it looks about it.
Yeah. And we had a system where you could turn them off with covers. So depending on what was cooked, we're going to go off a similar business model for, similar design for the version I was talking about, like the disaster relief trailer.
Sure.
And then we're going to try to go with smart controls. So you have the electric heating and you have temperature sensors in the food, and a chef can sit here and see what's happening in all 8 tubes and decide, whether a meal is done, turn it on, turn it off.
Sure.
Is the line of customers starting to grow? Okay, we'll turn on these 2 ovens that have just food ready and prepped, so that in an hour from now, I'm going to have more meals.
Sure.
In fact, that was a part of one of our designs. When we do our 2.0, we're going to build it out of fusion, individual fusion, and then you can just turn it off with the reflector. That's the GoSun station, first built. We built 6 of these. We sold 3, gave 2 away, and this is the last living. Well, I think there's 1 or 2 living somewhere else, but this is the one I held on to.
Sure.
This is the one that went to the White House.
Yeah. Well, it's good stuff. This will last through a nuclear attack.
It's gotten blown down while sitting in this location. You can see how this is all bent up.
Sure.
It got blown down 3 or 4 times and landed on its face, and I think we lost 1 tube. I think one of the tubes is popped, so I got to replace it. Yeah, this one. Yep. You can see there's no mirror in there.
Yeah.
And I don't know what direction.
Hand warmer. There you go. That's it.
Hand warmer.
Auxiliary hand warmer. Arm warmer.
I want to build them big enough so you can sleep in there. You want to go over to the shop? Yeah. Okay.
Yeah, sure.
Can you go check out the shop? Yeah. I think I got a grill over there.
Okay. Yeah.
This was a challenge to build this thing. The GoSun grill. So I showed you the trays in my home earlier, so the 2 trays go on there. And really a bomb-proof product. We actually found a way to, using just a couple parts, we found a way to increase the heat and the speed of this about 30%.
Wow.
We added like a thing called the turbo kit. But the sundial, I don't know if you've seen that. We call it the GoSun dial. Yeah. It runs on a glare rather than a shadow.
Sure.
So you can kind of see right now that door is kind of this white glare space.
Yeah.
So if that were the sun, we're pointed pretty well at it. You want it to align with the target that's beneath.
Sure.
That was a fun little innovation that you can kind of see the shadow that's generated by the little dot at the top.
Yeah.
So when that shadow and that glare align, pointed right at the orb. I think this is a 150 millimeter external diameter.
Sure.
And then, like you said, the inside is like 135, which is like 5 inches. Okay. So that's about the biggest that we were able to come up with. And you can see the big thermal mass there.
Yeah.
We had designed to have that gap be where we put the electric heating elements, but we couldn't fuel this thing on 12 volts, so we had to then go to AC power.
Yeah.
A whole different game and way more expensive.
Might get a little closer shot of that. That's right.
Yeah. Let's see what else. So much of what we're doing now is something other than an oven. But yeah, this is where the magic happens.
Yeah, you got room enough to elbow room. You got room to fail, room to succeed.
That's right. We got our little hardware store, so we don't have to go far when we need our bolts or paints. Or we did a bunch with electric. So these are electric heating elements that we were using to. We've been trying to develop a really low cost solar oven using our technology. Mm-hmm. And I mentioned I have one that we're about to go mainstream with. That's going to be about $40, but that product is real small. It's about the size of the GoSun Go. So we're trying to build something for developing countries for less than $100, and we think we can do it for 50 or 60. Yeah, this is Carl.
Hi, Luther.
And the way we decided that we would do it is the frame would have to be made out of something less expensive than sheet metal. So we've been looking at plastic and like coroplast and foam and sheet plastic, basically glorified cardboard that'll last. And so that's the product that it's been about 4 years in development because there's so much. Well, of course, there's many other things that we're doing as a business, but we're trying to get it field tested. We're trying to really proof it before we share it with the world because it's the one that really the most is on the line for the whole movement for my purposes. Like, if we're going to be popular in India or Kenya, we really need our technology to work, and it needs to be fail-safe out of the box. And so I want to make sure that the version that we manufacture in Kenya for $50, $60 is absolutely going to work. And then, of course, it'll take on some adaptations for that market based on what they like to cook, what have you. But we'll probably be involved in the kind of the utilitarian side of this is the way it works. This is how it's protecting itself to be super durable, because I know that's one of the big pushbacks is if it's a vacuum tube, how can it withstand the rigmarole of a third world country? And again, I think we kind of have that nut cracked, and now we're just kind of going through our final stages of refinement and we're doing some testing. We have some tests happening in Kenya right now before we then say, okay, GoSun has a sub $100 product for the masses in places that are energy starved and cook with wood and charcoal on a daily basis.
Sure. Quick question, and this is where I keep referring back to my trip last fall because it's an eye-opener. Gordy Bishop in Barstow, he worked in a solar thermal power plant, and when I visited him, he said, "I got to show you this tube that was basically, it wasn't one that we use at our plant, but it was like it. It was a tube, and it was a vacuum tube, but it was glass, and then it was the metal for the oil. Yeah, I'm sure you're
about to. It has those giant expansion absorbers.
Yeah, an absorber, and then a way to actually evacuate it if the seal,
right? Yeah.
And they can unevacuate it if they needed to repair a line. And the discussion we had was, and he said he's wondering if maybe that could be an option. So we're not talking about the inner tube imploding. which is it is still, even for as rare as it is, it's still the biggest concern. But if it were a metal thing and small enough, but you could have like those food vacuum things where you seal up a canning jar.
Right.
You know, if you could get it to that point, and then you'd never worry about that shattering, and then the outer one could be whatever, polycarbonate perhaps, or tempered glass.
I mean, it is a high vacuum, so it's not going to be the same kind of vacuum capabilities that you can at home type of thing.
Right.
It's very high Pascal, ultra low pressure.
Sure.
But I'm sure it would help, and then you could get it, if it was plexiglass, you could make it ultra durable too. Yeah, that'd be cool. Totally bomb proof. It's such a small industry, and then you have, like we talked about earlier, the context, the traditional or the cultural context of food.
Yep.
People don't want to change that much. I mean, they want to go to the latest fusion restaurant where the food's cooked and they know it's going to be good, but they're first going to look at the reviews and check out the menu. We're not, especially when it comes to food, that's where our ancient brain is, and we're not really that adventurous.
Okay,
Right, so this is the GoSun Sizzle, which we just recently launched. This is one of our fastest ever. This is actually manufactured in Canada by our lead investor, a guy named Glenn McGilvray. And Glenn's been in the clean technology movement for a couple of decades. He's done a lot with solar lighting in Africa. And when he found GoSun technology, it got him thinking. So this has a much wider wingspan, as you can see. Like the fusion is not as even as this wide. So this is like twice as hot, basically, as mentioned earlier. This will get about 650 degrees Fahrenheit, it's basically a perfect parabola instead of the compound parabola. So you do have to do a little bit more to tweak it, make sure it's pointed at the light. Made out of all acrylic frame. Real simple, as you can see, so everything can be maintained, everything can be replaced, and it's sort of our answer to, the people that want the GoSun grill is, well, here's something that is better, faster, it's equally elegant, durable, and it's going to last forever, and you get a meal done in a very, very reasonable amount of time, so you don't have to. There's no waiting on this guy.
Sure.
I have, from a cold start, I've put about 6 pounds of meat in here and had it done in less than an hour, like in about 45 minutes.
Sure.
So that's just as fast as an oven at home.
Well, and that's one thing that has come up recently too, is people saying, "Oh, the objection is it takes long to heat up." But what do you mean by so long? 15 minutes, 20 minutes? Sometimes you watch these cooking shows. They're heating up that pan. You get the oil smoking, then you put there's always a wait. I mean, there's always a wait. The fire to go up, the charcoal, for crying out loud. How many people it takes an hour because they can't get the right mixture of the starter and the
That's exactly right. Generally when you're solar cooking, there's a little bit more factors out of your control, and a little bit more patience is going to be needed. But the sense of accomplishment is pretty high when you cook your own food without using the fire, and that's a really rare. You're in the 1% of the world when you're living exclusively on the sunshine. Yeah.
Well, this is a space age look. I mean.
Yeah. Isn't that wild?
Yeah.
And then you can kind of, like, if you don't want as much heat, you can do that. If the food, maybe 10 minutes before the food is done cooking, shut it off. That's going to hold on to heat and continue to cook. Yeah, it's a nice product. Real easy to throw around. Certainly not as portable as other GoSun products, but maintains. You can bring it in and out every day if you have to. If you're cooking on the backyard.
Sure.
Hey, Shadow, why don't you go lay down? Go lay down. Hey, go lay down. Go lay down. Go lay down. Go lay down.
He's trained you well.
She is just so neurotic. Nope.
You're a good dog. Here.
Yeah.
Here. Oh.